Hi, this is Rodrigo Fuentes. I'm Product Sales Manager for Vmware at Adistec. And today we're going to be talking a little bit about SD-WAN, but not just the regular SD-WAN, but SD-WAN by VeloCloud, Vmware VeloCloud. And before getting into the solution and what makes VeloCloud a different SD-WAN solution on the market, I would like to go a little bit on an overview on why SD-WAN, why exactly SD-WAN and the need for SD-WAN. So we have here the headquarters for a company. We have several branches, and these can go all the way from one to, I don't know, thousands of branches. And not only branches, but maybe remote offices or kiosks or maybe remote workers. We can even talk about ATMs. We have customers that treat each of their ATMs like if they were a branch. And in each of these locations, we have different CPEs or routers that will take the connection from their private link on each of the branches and connect to the data center. Usually, this connection is one to many. We don't have connections between one branch to the other. Usually, if you need to talk to one branch from one branch to the other, you have to go to the data center and then come back. Or you have to go to the MPLS network and then come back. And this MPLS network is usually not that fast. We can be talking about, depending on the country, usually speeds like 10 megs to each branch. And the prices for these, I have seen around the area, there is around maybe, I don't know, $100 for 10 megs, symmetric 10 megs. But that depends a lot on your country. But the thing is that these links are expensive. They may be reliable, but they are not as fast as the internet speed that you may have at home. Now, usually internet is connected here on the branch, on the headquarters. In case I need to go to any internet resource like a cloud service, the branch will have to go through the private link, go to the headquarters, and then to the internet in order to get to the cloud. The thing is that this will make bottlenecks. It will make bottlenecks here. It will make a big bottleneck over here. And then I will have a bigger pathway to the cloud via the internet in which I will go and be able to consume the service. So I'm facing a couple of issues here. These routers, I have to configure them one by one. So in case I have 100 routers, the IT administrator, the networking administrator, will have to go and configure each of these, and he will have to configure all of the security policies, all of the networking policies, all of the QoS, because I have applications here. I have voice over IP. I have instant meetings. I have like WebEx, Zooms, Meet, Teams, etc. I have other services, maybe not that important, not as crucial, like, I don't know, backups. So I have backups running here. I have antivirus actualizations and updates. I have many different services that are running through these networks in which I need to provide QoS. I need to provide security. I need to provide routing, segmentation, etc., etc. And all of those settings, policies, and so on have to be configured manually on each of these devices. Usually, these devices are provided by service providers. Usually, these devices are provided directly by the customer. But no matter what, these configurations have to be done manually. So we have something to work here, and it's management. Management is complex on these situations. Now, performance-wise, we talk about the bottleneck that gets into place whenever a branch has to communicate within each other. Let's say that I have a phone call from branch 1 to branch 2. So that voice over IP there's no link between these two branches. So they have to go all the way to the headquarters and then come back. If this is a cloud voice over IP solution, it will have to go to the headquarters, then to internet, to the cloud, and then come back to the other branch. So performance is not always as we desire. And then performance. And then the other thing that we have is this guy that we have over here, cloud. I will say that 95% of the companies are already consuming some kind of cloud service. You may call it AWS, you may call it Azure, maybe you call it Teams, 365, any kind of service that you can imagine that runs on the cloud. How does these guys get to those services? Through the WAN. And in case they have internet connectivity, which is not the case in most of the branches because of security policies, because of the usage and control and monitoring that I need to have on those connections, they will anyways go through the internet as a plain connection. So no security on those connections to the cloud, on those services to the cloud. So keeping that to mind and considering all of these three aspects that are really and crucial for WAN, is that SD-WAN comes into place. First, I'm going to talk about the general concept of SD-WAN. So SD-WAN is something called overlay architecture. And this overlay, or overlay WAN, will actually sit on top of any infrastructure that is already running. But the nice thing is that this would allow me to run a WAN on any link that may exist or that may be available on each of the branches. And there are two main components on VeloCloud. The first one, is the orchestrator. So there's a VeloCloud orchestrator, which is a SaaS service. And this VeloCloud orchestrator is a web service that will allow the administrator to configure all of the policies for all of the devices on all of the network. Which devices? Well, these are called VeloCloud Edge. And the VeloCloud Edge may be physical appliances, or they may be also virtual machine appliances, depending on the design that we may work for you. This can be either physical, they can be virtual. We can run it on cloud, we can run it on premise. I'm going to talk a little bit more about cloud in a while. But this VeloCloud Edge will be able to get all of their configurations from the orchestrator. That configuration includes something called deep application recognition. And what deep application recognition does is that it will take all of the policies configured on the orchestrator and will be able to identify the application and apply those policies to that. So for example, if I have voice over IP going through this edge, then the device, the appliance, will know that it has to provide the best possible performance and the best possible connection to that for that application all the way through the network. It will apply different levels of security, leaving different kind of optimization for that application. Now, this will actually work in a way that is completely transparent. I just go deploy the appliance, and once the appliance is boot up, it will take the whole configuration. Now, the other cool thing is that this overlay technology will allow me to get multiple connections into the same device. So for example, I can connect these devices to 4G, 5G networks. I can connect these devices directly to internet. All of the security policies will get applied directly to the device. So there is no need to go and configure these policies to each of the sites. They already know how what are the applications that can connect to the internet, what are the different different kind of communications that can go and that cannot go to the internet or through 4G or 5G. But the cool thing is that together with DAR, it used something else called dynamic multipath optimization, which is another superpower for SD-WAN by VeloCloud. What this does is that it will take all of the links from one branch and will aggregate all of those in order to be able to measure how good the link is, how fast, how much delay does it has, how much packets are being lost. And then depending on that and depending on the type of application that is running, then it will identify where to send the information to so that it can reach to the other side. And that other side can either be a branch, it can be the headquarters, or it can be the cloud. And that's actually done per packet. So what it means is that since it's per packet, I can steer from one connection, from one link to the other, in case there's a bottleneck in one of the links, or there's one that is having more delay, or actually the whole connection gets lost. Then I can just switch that packet and the rest of the packets to another link. That's actually per packet steering that we call, and it's done in real time. So there's no downtime. There's no like 30 seconds or so to get and do the failover. It's done instantly. That's a big difference from SD-WAN by VeloCloud. It would allow to have high availability on all of the links, no matter if they are 10 megs, 100 megs to the internet, or maybe 50 megs to the 4G, 5G network. It will take as much bandwidth as possible from all of the links at the same time. And if feasible, depending on the application and the kind of connection delay and so on, it can use the same, all of the networks, all of the links in order to transmit the data to the other side. Now, the final thing that makes SD-WAN completely different is that on the cloud side, once I need to send an email, let's say Office 365, or I need to make a Zoom meeting or something like that, I would just go to the internet and that's it. That's the end of my WAN. But with SD-WAN, it's different. Actually, SD-WAN has, you don't see them yet, but you'll see them in just a couple of seconds. There's a lot of points that I'm doing over here. And let's imagine that each of these points are actually what we call VeloCloud cloud gateways. And what are the cloud gateways? Well, they're actually similar to the VeloCloud Edge, but are made in a way that they're really close to the cloud solution. And they're really close to the cloud provider, actually, so that in case I need to send or use any kind of Office 365 service, I can use the same definition, the same policies, the same security that I have with SD-WAN by VeloCloud to reach these cloud gateways. So that would allow your company, using any kind of cloud solution, either if it is infrastructure and you have it on Azure, Google, AWS, or so on, or if it is a SaaS solution, to be able to be optimized and secure, encrypted, and control and monitor through all of the path to the cloud and back. And this is why Vmware SD-WAN is different from other SD-WAN providers and other SD-WAN solutions. It's not only about an overlay one, but also about how we can provide the best performance, considering all of the links speeds and not wasting any of their performance, and also being able to switch from one to the other in case there's a failure. But also how we can put cloud into this SD-WAN architecture. Being able to provide the same performance monitoring and control from any communication that goes from the branch's headquarters, remote workers, all the way to the cloud and come back. Thank you for your attention today. This is Rodrigo Fuentes, and thank you.